Hello, welcome to the last lesson of week 5. In this lesson, we're going to take a look at absolute value equations. You'll be able to use, again, the properties of equality to find solutions to absolute value equations. Well, I've just introduced a new idea of absolute value. What is absolute value? Or when will it be used? So I'm going to give you an example of like a race. Let's say I ask you at what time this motorcycle is 100 feet away from the grandstand. And the grandstand's where the finish line would be, where all the fans are at. And if you think about it, he's 100 feet away from the finish line twice. He's 100 feet away as he's approaching the finish line. And he's also 100 feet away as he's past the finish line. So we have two answers to this: the time that he's approaching and the time that he's past the finish line. So this one would have two solutions. Okay. Absolute value doesn't care about signs. It cares about number of units. It's a distance away from zero. So if I ask what two numbers are 100 away from zero, you would know that it would be positive 100 and negative 100. The way we write that is using little bars. They look like parentheses, but they're straight. You see it right here. And we read that the absolute value of negative 100 equals 100. Now, a lot of people think that means you take the opposite sign. That is not true. The absolute value of positive 100 is also 100. When you see the absolute value, it's saying how far is this number from zero. So the absolute value of negative 100 is 100, and the absolute value of positive 100 is 100. Now, when we're solving absolute value equations, we still want to isolate something. However, we're isolating something else. We're not isolating the variable yet. We will, but not yet. What we're isolating first is the absolute value expression. We're isolating whatever's inside those bars. Okay, and one thing I want you to note, the isolated absolute value expression needs to equal a positive number in order to have solutions. We'll talk about that in a little bit. And then after you've isolated the absolute value expression, you want to write a pair of equations. And I underline the word pair there because, like I showed you with the motorcycle, there are two solutions to this typically. So example 1 is one of the most basic ones. What are the solutions of the absolute value of x equals 7? Before I go any further, I want you to see that the variable's inside those absolute value bars. That's what makes it an absolute value equation. Well, what two numbers are 7 units away from 0? Well, negative 7 or positive 7. So those are my two solutions. Notice what I did. The x didn't change. X equals, and I put the negative with the 7 and the positive of that number as well. Okay, so let's take a look at a little more complicated example. What happens when you have something like this? Again, the variable's inside the absolute value bars, right? But the absolute value expression, 2x plus 6, is not isolated. I've got minus 4 here, and I've got the 3 on the outside. We want to isolate that first. We want to isolate the absolute value expression. Note, one thing that a lot of people will do is they will distribute the 3 into the 2x plus 6. You cannot do that. You cannot distribute into absolute value. It's not parentheses. We need to move the 4 and the 3 before I can do anything else. So how do I do that? Well, first I'm going to rewrite the equation. I'm going to add 4 to both sides, which gives me 3 absolute value of 2x plus 6 equals 24. Now, since I can't distribute that 3 in, what I'm doing is I'm doing 3 times this expression. So I can undo the multiplication with division. So I'm going to divide both sides by 3. And I get the 3's canceled, and I'm left with the absolute value of 2x plus 6 equals 8. A lot of people are going to want to subtract 6 and divide by 2 now. Please don't. What do we do once we've gotten this part? We've gotten step number 1 completed. And that, just a reminder, was the absolute value expression is now isolated. Okay. What I want to look at now, before I move on, is the absolute value expression is equal to positive 8. That's good. That means we can continue with this problem. little foreshadowing for the next example. So now I'm going to write two equations. Well, what two equations am I going to write? Well, I want whatever's in here to equal -8, because if the absolute value, if I can get an x value that makes this -8, then I've got the absolute value of -8 is 8, and that's a true statement. So I want to know what is going to give me -8. Or I could also get this expression in here equal to +8. So 2x plus 6 equals -8, or 2x plus 6 equals 8. I need to solve both of those now. They are solved the same way, but let's just go through it real quick. We're going to subtract 6. 2x equals -14. Divide by 2, I get x equals -7. A lot of people will say, oh, just -7 and +7. Don't do that. Please watch the next part. Again, we're going to subtract 6. 8 minus 6 is 2. 2 divided by 2 is 1. So I get two very different solutions. Both of them need to be written down. X equals -7 or x equals 1. Example 3, no solutions, telling you what happens. But first step is we need to isolate the absolute value expression. I need to move the 17. So I'm going to subtract it from both sides. So I get the absolute value of 5x minus 9 equals -7. The absolute value expression is isolated. There's nothing on the outside of that absolute value bar. Notice how the expression is equal to -7. Can an absolute value expression equal this? No, it cannot. I cannot take the absolute value of a number and get a negative answer. It doesn't make any sense. So what can I say? What I would say is this equation has no solutions. And that concludes week 5. Start preparing for your assessment.